Hi everyone! In this video I want to do an overview of hardware and software requirements. You will know that what is typical setup for data science competitions. I want to start from hardware related things. Participating in competitions, you generally don't need a lot of computational resources. A lot of competitions, except image-based, have under several gigabytes of data. This is not very huge and can be processed on high-level laptop with 16 GB RAM and 4 physical cores. Quite good setup is a tower PC with 32 GB RAM and 6 physical cores. This is what I personally use. If you have a choice of hardware to use, I suggest you to pay attention to the following things. First is RAM. For this, more is better. If you can keep your data in memory, your life will be much easier. Personally, I found 64 GB is quite enough, but some pro-kegglers prefer to have 128 GB or even more. Next are cores. The more cores you have, the more or faster experiments you can do. I found it comfortable to work with 6 cores, but sometimes even 32 are not enough. Next things to pay attention for is storage. If you work with large datasets which don't fit into the memory, it's crucial to have fast disk to read and write chunks of data. SSD is especially important if you train neural nets on large number of images. In case you really need computational resources, for example, if you are part of Metal Hunter team or have a computational heavy approaches, you can rent it on cloud platforms. They offer machines with a lot of RAMs, cores and GPUs. There are several cloud providers, most famous are Amazon AWS, Microsoft Azure and Google Cloud. Each one has its own pricing, so you can choose which one best fits your needs and budget. I especially want to draw your attention to AWS Spot option. Spot instances enable you to bid on unused instances, which can lower your cost significantly. The hourly price for a Spot instance is set by Amazon and fluctuates depending on supply of and demand for Spot instances. Your Spot instance run whenever your bid exceeds the current market price. Generally, it's much cheaper than other options, but you always have risk that your bid will get under current market price and resource will be terminated. Tutorials about how to set up and configure cloud resources you may find in additional materials. Another important thing I want to discuss is software. Usually, rules on competitions prohibit to use commercial software, since it requires to buy a license to reproduce results. Some competitors prefer R as basic language, but we will describe Python stack as more common and more general. Python is a quite good language for fast prototyping. It has a huge amount of high quality and open source libraries, and I want to review several of them. Let's start with NumPy. It's a linear algebra library to work with n-dimensional arrays, which contains useful linear algebra routines and random number capabilities. Pandas is a library providing fast, flexible and expressive way to work with relational or tabular data, both easily and intuitive. It allows you to process your data in a way similar to SQL. Scikit-learn is a library of classic machine learning algorithms. It features various classification, regression and clustering algorithms including support vector machines, random forests, gradient boosting, k-means and a lot more. Matplotlib is a plotting library. It allows you to do a variety of visualization like line plots, histograms, scatter plots and a lot more. As IDE, I suggest you to use IPython with Jupyter notebooks, things that allow you to work interactively and remotely. The last property is especially useful if you use cloud resources. Additional packages contain implementation of more specific tools. Usually, a single package implements single algorithm. XGBoost and LikeGBM packages implement gradient-boosted decision trees in a very efficient and optimized way. You definitely should know about such tools. Keras is a user-friendly framework for neural nets. tsnE package is an efficient implementation of tsnE projection method, which we will discuss in our course. Also, I want to say a few words about external tools which usually don't have any connection with Python, but still very useful for competitions. One of such tools is Volpelwebit. It is a tool designed to provide blazing speed and handle really large datasets which don't fit into memory. libfm and libffm implement different types of factorization machines and often used for sparse data like click-through rate prediction. RGF is an alternative tree-based method which I suggest you to use in ensembles. You can install these packages one by one, but as alternative you can use Python distribution like Anaconda, which already contains a lot of mentioned packages. At the end of this video I want to emphasize that proposed setup is the most common but not the only one. Don't overestimate the role of hardware and software, since they are just tools. Thank you for your attention.